Let me just check something. Check something. Check something. All right. Good morning from wherever you are. So today this is my tutor's project. I was supposed to do it in class, so I decided that I did not attend the class for these 2 days. So this is what they did, and I want us to go through this Python file and also a Jupyter notebook that we have over here, and understand basically what my tutor was trying to do here. So remember, this is a beginner's thing, so I also don't know. And welcome. My name is Pranjay from Kenya. All right. So in the EDA, first of all, let's go to the project structure so that we can understand what is happening. So the project is called Dev Salary, and we are going to develop a Streamlit app eventually that predicts the salary of a developer based on their country, years of coding, education level, employment, and also languages they have worked with. So this the data set we got them from what's the name of that site? Stack Overflow. So we got the data set from the Stack Overflow, and it's just the developer survey. So yeah, let's get into it. Let's start from here up here. So this is a exploratory data analysis. This is the exploratory phase. We're trying to understand what this data contains and why certain things where they are and why they are there. All right. So you want to check the columns, the rows. How many rows and columns do we have? All right. So we start by importing pandas as PD, obvious, NumPy, Matplotlib, and Seaborn. These ones are used for plotting, right? PD.set option, display maximum columns. Also, disclosure guys that we're going to be using Cloud Code and also ChatGPT to get some of the answers we are trying to understand. They will help us to understand this project better. All right, since we are all beginners, so step at a time. Okay, first of all, we load our data. This is a loading step, and data loading. So df, so we read CSV, and here this is a different method because remember we've created different folders over here. So I want to understand why we've written this. It's because we're trying to show the direction where our CSV file is located. Okay, so when we place these two dots, it means we are going backwards. We're in a folder, right? So we're in the notebooks folder. So if we place the single dot, we come out of the notebook folder, right? And then we go back to the original folder. Now we're in the dev salary folder, right? Now from the dev salary folder, we move to the data folder, which is this one. And then we move to the row folder. We have the row folder here, okay? And now finally we go to the developer survey. So it's actually this should be row, I think, yeah, because I wrote the row with capital letters. Yeah. Yes, and then we finally the document, the CSV document. All right, low memory false. By default, it is always true. So if it is false, it shows that we are not going to process the data in chunks. All right. So it means we're going to be using more memory. All right. Okay. So first of all, we print the shape of our data. So we want to see how many rows and columns we have. And then we also want to see the length of the columns, the number of columns we have. Okay. I think all right. Yeah. So how many rows do we have? 49,191 and 172 columns. Columns, we want to know the number of columns. It is 172 columns. We have just got it in from the shape, but right. Print the first 5 column names, that is as a list. So we cast them to a list, and then the df dot columns from column 0 to 5, right? That is 0, 1, 2, 3, 4. Okay, it won't get 5 because indexing. Okay, so 0, 1, 2, 3, 4. Okay, here. These are the first 5 columns because according to our indexing, we start with 0. Our target column, we have our target column. Remember, we have a target in machine learning and all that stuff. We always have the how to call it, the features. Okay, so the target is our end goal. It's like saying x is equals to when we say, for example, it's like saying y is equals to mx plus c. All right, so this y, now the gradient, and then x is the x-axis, the values on the x-axis, and then c is the y-intercept, right? So what I mean by target is y. Okay, what are we trying to get? Okay, we are trying to predict the salary of these people. Okay, so that is our target. We're trying to predict a salary, so that is the target. Okay, and then now the features are the x. Okay, this is basic for how do we call it, linear regression, simple one. Okay, this is the equation that it utilizes. Okay, all right. So target column is converted compensation yearly. Okay, how much are they being compensated yearly? So you print, we want to confirm if this column exists in our data set. So target call in df columns. Okay, target call. All right, now this converted comp yearly, is it in df columns? Right, true. If it comes true, then it means it's present. Okay, all right. We come to the want to see how many in this cell here. We want to see salaries that are available because our target is salaries, right? So we are targeting compensation, which is just salary, right? So here, one check the salaries available. Okay, so how many salaries, how many rows have salaries in them, all right, and which ones do not have. Okay, so salary available, df, the target column, we remember, is the converted compensation yearly. Not now is not NA is not available, or you can just say not. Yeah, it's a null value. We don't have a value inside it, so we want to see how many are not available. So it means here we have values, all right? So in this one, the first one is so not now is we have a value in a row, right? So not now dot sum wants the number of rows that have values. This one just tells us the number of rows with we do not have a value in this row, all right? All right, okay. So rows with salaries are available here. Ones are missing salary here. So it's null.sum is, remember, is checks which ones are null and sums them. So to tell us the total number of rows without such, without values. Okay. So coverage here, what we've done is we've gotten the salary available over the length of df. Okay. The length of our data frame. Okay. Times 100. Now the length of a data frame, I want to check, first of all, I want to check what is the length of a data frame. Let me just add a code here and check. Now I want to print. All right. The length of a data frame is the length of our rows. Okay, just the number of rows that we have. All right. If you come up here, you remember we did the shape. We were having the number of rows. Perfect. Also, we don't have to finish this thing today, but it's just my first live stream, and I wanted to just do it because I have to do it. Yeah, I told myself and I owe it to myself. So yeah. Now here, what we are doing here is we are dropping we're dropping empty rows. Okay. I hope so. Let me see. Empty rows. Df data column drop now. Drop not available, and then describe, right? So here return yeah. So we are trying to drop now. So we are dropping null values. So the ones with now you see we want to drop these rows. So we'll drop 25,244 rows. So it means rows that remain is 20,000. Okay. So and then you can also do df prints length of df. Now I want to see if I can print the tab. the length after we've dropped empty rows and see how many will remain, right? Now describe will give us what? Statistical descriptions, all right? These are the standard deviation, the means, the upper quartile, lower quartile, okay? So let's see. Perfect. Um, okay. Df tile column the truth now. All right, let me see. Let's just use our friend over here and understand what we're trying to do over there, right? Okay. So let's go to cloud and try to get an explanation for what we're doing. What does this code mean? Right, breaking down the code, this code, analyzing code. So df is short for data frame, is like this spreadsheet. Python holds rows and columns of data. So target column picks out a specific column from the spreadsheet. Yeah. Drop now removes any empty or missing values from the column and stands for not available. Cells with no data in them. Describe gives quick statistical summary of the remaining data. Okay, right, perfect. So I think there's a cell that I missed. I didn't run. Okay, this is a target column. So I ran the cell. Then I did this. Okay, then there's the length. Okay, and then here I wanted to. Yep. Okay, perfect. Now if I come to here, let me add a cell over here and see if it will have different things, right? Df targets column tab. Okay. Let's see. Perfect. So we have this is a description count 2 pointers. Okay, these ones are times. That's an exponential. You see, we have exponential values. All right, name converted completely. All right, perfect. So still have this. Now we want to drop empty rows. Okay, repeat again. 49 191. Now let's go here and ask again what's happening. Okay. Perfect. Now, oh, I remember what the difference now. Initially, this one we did not save it in the data frame, so we did not alter the data frame. If we were to place in place is something that we read there in place, it will change this the whole data frame. So here we're still not yet saving the data frame, so it did not modify the data frame. It only temporarily dropped the none values to calculate the summary. The original data frame was never changed. This does not change data frame. Result is thrown away. So the data frame still has all its original rows, including the none values. Alright, perfect. It's just a same temporary solution. To actually remove nuns, you need to save the results. Alright, so cleaned, this is this, none. Now print the length of cleaned. Now this will be smaller. Okay, now this makes sense. Alright, let's continue. Alright, so here, so this does not dropping empty rows temporarily, okay? We're just trying to get statistical, what? Statistical values here. That's what we're doing here, okay? After dropping the the nulls, okay? What has changed? What has changed? What can we see has changed? Standard deviation, mean. Okay, nothing has actually changed. So 1.2, okay, there's no change at all. Perfect. Now here, we are now going to put in place, okay? And what we are doing here is we are replacing the rows salary df between 10,000 and 500,000. So we want to change to now see this that we are what we're doing here is we're replacing we are targeting, okay, we are going to the df, okay, then we are selecting this column, okay, the target column, and then we are selecting between 10,000 to 5,000. Now this is the salary df, all right? So our data frame only contains values from 10,000 to 500,000. Let's use cloud to understand this even further. What does this code mean? Perfect. This code is filtering rows from the data frame and saving the results into a new variable called salary df. Grabs target column salary dot between, checks if each value is between 10,000 and 500,000 inclusive. It returns true or false for every row, right? True, false, too low, right? Okay, false, true, right, none, false. Df, now the outer df uses true values to keep only the true. Now the outer one uses those true or false values, false results to keep only the true rows. Salary df saves the filtered result into a new variable. The original df is unchanged, right? Simple analogy. Imagine filtering a list of job applications by salary expectations. You only want people expecting between 10K and 500,000. Everyone outside that range gets excluded from your new shortlist. All right, so it's between 10K and 500K. If you're out of that list, if you're out of that range, you are excluded. Okay. If yes, if no. Contains outlast, yes, no. Row count original, this one will be smaller, obvious. So we have a new df and it has figures ranging from 10,000, 500,000. So I think what he was doing here is to filter. All right, filtering. Okay, filtering rows with values in that range. All right, so we wanted to plot. Okay, fig axis, we want to plot subplots. These are plots that are side by side. Okay, the size, we set the fig size. We have subplot 1 and 2, so we have column, right? Yeah, subplots. So let's just look at it. Now the rows, how many rows we have? 1. How many columns will we have? 2. So that's what 1 and 2 stand for. Okay, perfect. And then the size, the figure size, is it yeah, the figure size. Okay, now perfect. Column. Okay, column will contain row distribution. Okay, axis, we're going to plot a histogram, salary df, this one, and then we're going to go into it. We're going to go for the target column. Okay, 60 beans. What does beans mean? We're going to check that. This still blue edge color. So we are going to have an histogram of target column. Okay, and remember this will be between 10,000 and 50 and 500,000. Okay, what is happening now? Okay. Okay. Let me connect my mouse just a moment. Okay. Okay, so this is the first axis, the axis 0, and we've said this is the first column. Okay, remember we are doing between 10,000 to 500,000, so this salary DF has already limited the rows to this number of to rows only containing these values. Okay, so this means that when we come to now, okay, we're setting title, salary distribution, USD, font size this, we are going to check what beans means. X label, annual count, that one, that's the x-axis. So we want to see, here we are checking these rows, what the number values in the rows. Okay, yeah. Log scale distribution is just this. Now there's a second column. Now again we're plotting a histogram, and then these are log of these values. Okay, log of those values. So NP, that's why we add numpy. Numpy is for doing mathematical or statistical calculations for us. Okay, now NP dot okay, so it has log 1p. Again, we select salaries, being 60, color, coral, edge color is white. Now set title is log salary distribution, log annual distribution. So remember, log is a different scale. Okay, log is a different scale. This one is a normal scale. This will show us where most people are. This will just show us the log of that. Okay, and then set y label is a count. Okay, so how many people, now this histogram will show us how many people earn salaries between 10,000 500,000. So if we have 10,000, how many appeared? If we have 11,000, how many appeared? Okay, that's the y label. So that is what this histogram will show us. Okay, PLT type layouts, PLT save fig. Now we are going to save them in data, and then let me change this to D, capital D, because of how I've saved mine here. It's capital D. All right. So we're going to save. Okay. DPI 300 PLT show. All right. Now let's see. Let's run this. It's going to save in my data folder here. Okay. If I don't have that, it will bring an error. All right. Perfect. Now look at this. This is what we're saying. This is a normal without a log. Okay. We see 10,000, 20, 200,000, 300,000, 500,000, 500,000. This guy is outside alone. Okay. So this is the data. Okay. So the highest people are these ones who have just something less of 100,000. Yeah. And there are about even more than 1,400 people. So, yeah, around all right, there around 1,500. Okay, even yeah, around 1,500 or just slightly above 1,400. All right, perfect. The other thing is log salary distribution as well is a log values log of these ones. This one I want to know why it looks like this compared to this one. So we'll go and check that on cloud and get an explanation for that. All right. So we have the mean salary is 98,000. Median salary is the central salary 81, 270. Okay. So I want to we'll understand this. Just okay. Let's just do it right now. Okay. So let's just understand what this means and why is it different from the other one, right? Okay, perfect. So why are the two graphs different? So that is what we need an explanation for that, right? Scale is different. One shows row salary numbers and the other compresses them using maths. Graph 1, row distribution, still blue, plots actual salary values 10,000, 500,000. If most people earn between 40 and 20, if you read the graph, it looks skewed, obvious, yeah. Like for ours, we've seen the graph is very skewed to the left side. Okay. Okay, graph 2. NP log 1P compresses large numbers and stretches small ones. The huge gap between 10K and 500K gets squashed into a smaller range. This means the distribution looks more bell-shaped and symmetric. Okay, perfect. So why use log scale? Situation use, you want to see actual salary values, row. That is heavily skewed with the class. You use log. You want a clean and symmetric shape. Log. Feeding data into a mail. Use log. Models prefer symmetric. Models prefer symmetric data. All right. This is a Gaussian distribution. So here we can see it's skewed towards the left. Okay. Well, this one is small. yeah, the bell-shaped size, bell-shaped distribution. All right. Uh-huh. Let me see there. Was it called the Gaussian distribution? Yeah, the Gaussian distribution, commonly called the normal distribution or the bell curve, is a continuous probability distribution where most data points cluster around a central average. Okay, tapering off symmetry towards the extremes. Now this is a Gaussian distribution. Perfect. So this one is what we're trying to do here. We're trying to visualize Yeah, we're visualizing the dataset, limiting ourselves to rows with values within the range, right? And we saved that. Now we're to confirm if we've saved it. Yeah, here it is. Okay, all right. Now, what is have we written it? plt.savefig. Where are we saving it? And then DPI. All right, perfect. Explore the selected features. All right, features are country, ES code, education level, employment, language you've worked with. For column in features, now it will go through all of them. Okay, if call in df columns, okay, missing percentage df call dot isna dot mean times 100%, unique count df call n unique, the number of unique values, and then returns the actual unique items. Okay, perfect. Now what we're doing is for every, now we are coming to each column for country. Okay, we go in df.columns. Okay, missing percentage df.call, now this column, checking null values and giving us the mean and doing the percentage of missing values. Okay, so for column in features, so each column will be selected. Now we'll start with country. Okay, this is a column. First of all, this is a column. First column is country. Now we go to the df data frame. If country in data frame, now if country exists in our data frame, get what? The missing percent, all right, of that column. Now that's unique count of values in that column, and then you print and then the name of the column and then the missing percentage, you just see. All right, now for we'll go from country, ES coded, education level, employment level, all these. All right, if it doesn't exist, it won't bring us anything. Okay, so now the goodness about this, if let's say let's put an error here, right? Put ear code pro, it won't bring us an error, right? Because this doesn't exist. Okay, so it will just jump it. Okay, so we've started country, then there's employment, then there's education level, and then the language I've worked with, right? As you can see, that is the thing that's happening here. Employment, you see, so we have 1, 2, 3, and 3. How many have we selected? 1, 2, 3, 4, 5. Now so it has truncated them. It has not displayed everything. Okay, 1, 2, 3. All right, it should show me others. So let me put ears coded and run again. Perfect. Yeah. So as you can see, the goodness of using for loops and ifs is if there's an error, it will just jump it. That's the usefulness of the for loop, right? So they're giving us the missing percentage, missing 27%, yes, 28% is missing. Unique count will give us 177 unique values. First 5 rows, the country. Now we'll get United States of America, we'll get the number of the number. Okay, Germany, how many of them? India, how many of them? Blah blah blah. France. No, these are the top countries. Okay, first 5 rows. Okay. Now df column dot value counts dot head to string. Okay, it's the value counts. Excuse me. 7,233 is the value count. Okay. Now what does dot head to string? I know it's converting it to a string now, but what does dot head mean? Let's come in and get an explanation. Dot head keeps only the top 5. Okay, perfect. Top 5 rows default. You can change it. Okay. All right, perfect. So dot head, that was the function of dot head. Okay. Now we are almost done. Okay, perfect. So this is another plot. So df salary, df target. Now we are going between returns boolean functions. Copy. Now now we want to see. I want to see what's right. Was df. Now the first remember the outer one was going to count only the true values. Okay, so so type column between now 10, between 10,000 and 400,000. Okay, now we are going for the title column again. The difference between that and this is that between is different. Okay, you can see this is 10 like that, and this one is 10 underscore. Okay, this is that one. Okay, top countries, df salary country. We can select country column. Dot value counts head 15 index. Dot index removes the counts. Okay. Country data. Df salary is in top country. Okay. PLT order country data. Order equals to country data dot group by country using the target column. Group by country. Okay, and then target column you convert to get the median, and then sort values in ascending, in now descending order, and then remove the counts. So we're grouping by country. Okay, using the target column, which will give us the number, the salaries. Okay, we'll find its median and then sort values, okay, in descending order. All right, SNS.boxplot data equals to country data, not this one, this guy here is what we plot. X equals to country, Y is equals to target column, order equals to order, palette equals to warm, Y label, tight layouts, save fill and show. Okay, let's see what will appear here. Okay, perfect. So we're getting a box plot. Remember, we're plotting box plots, and let's remove this. It's saved there. This graph was saved as well. So let's see, what were we trying to do here? So here, first of all, we've taken the range between 10,000 and 400,000. Okay, and then we made a copy. Okay, now dot copy, we've copied this data frame. Okay, now top countries is DF salary. You go to the country, select dot value counts, and then dot head, now 15, top 15 countries. Okay, then index removes the counts. Okay, country data, you take this one, and then you now in place again. Okay, now country data will be having countries that are in top countries. Okay, is in, you see, is in top countries. Now we select this column dot is in top countries here. So if that country exists in top countries, it will give us true. And then this one, now we'll take that number and say count that number. All right. So country data, that's it. If it's true, it's accepted into this country data. Okay. Now fig size, we've given it, and then order. Now we are ordering these things. We are ordering country data, all right, and then you're grouping it by the country, because remember, country data contains countries and the country, the number of times it appears in our whole data frame. Okay, between these two values. Okay, and then we're using this column. Okay, we are grouping by country using this column. Okay, and then we do the median of that column, and then we sort values in descending order. Okay, dot index removes the counts. Okay, yeah. Now we are using box plots. Now data, we are using country data. Okay, here we have countries and the counts. Okay, so X is a country, Y is the target column. Okay, target column is the salaries, and then you order by this order, then political war. Okay, so Y will give us the number, the salaries, and then this one will give us the country. Okay, country data. Okay, and yeah, this is what is happening here. Yeah, perfect. The next one is what columns have we selected here? We're trying to, this one are here, you see here your features. Okay, now here we've selected columns. This is target column, country, years code, education level, employment. Right, we've dropped country. Where is just features? Okay, employment, years code, country. We've dropped country. Okay, we've dropped country. No, it's there. Years code, education level, employment. Something has been dropped here. What is it? Language. Yeah, language. Okay. Now, total column of country, yes, code, education level, employments, available columns. Mm-hmm. Mm-hmm. So available columns is C for C, okay? C for C in selected columns if C in df columns. What we are trying to do is we are saying variable C, okay? For C in selected columns, we'll do follow here. If C in df columns, if C is present in all our columns in our data frame, okay, it will tell us if it's true, okay? It will give us a list. Missing df equals to df brackets available columns dot isna, okay? Now here, missing df. Now, do we have null? Do we have null values? Okay, null rows, okay? Now we want to plot. Now I think what we are plotting here is we want to plot this guy missing values, okay? So plt fixed size SNS heatmap missing df sample minimum 100 length is this one, all of them 1000, okay? Random set 42 c bar false y ticks x ticks cmap missing value map red equals missing. Okay, perfect. Let's see. Yeah, so see if red equals missing, we'll start with that df. Okay, perfect. So converted yearly. So we're starting with minimum values from 1000 to the length of the data frame. Okay, yeah. So it's just going to check the counts of missing values, and it will tell us now. Now these red lines show us the missing values. Okay, here. Okay, country here. Yes, coded here. Yeah, just like that. Okay, so we are done with the exploration phase. We've explored this data and we've seen the missing values of these columns. So we'll continue later on into the preprocessing Python file and understand what he was trying to do here as well, right? So I think we're done. Yeah, thank you. If you are here, thank you.